Objective 4. Construct and interpret a confidence interval for a population mean. Constructing a 1 minus alpha times 100% confidence interval for a population mean, provided that the sample data come from simple random sample or randomized experiment, sample size is small relative to the population size, and the data come from a population that is normally distributed with no outliers, or the sample size is large. Now, a 1 minus alpha times 100% confidence interval for population mean is given by the following. The lower bound is equal to the sample mean minus the critical t-value times the sample standard deviation divided by the square root of the sample size. The upper bound is taken as sample mean plus the critical t-value times the sample standard deviation over the square root of the sample size, where t alpha divided by 2 is the critical value with n minus 1 degrees of freedom. Because this confidence interval uses the t distribution, it is often referred to as the t-interval. Make note, the margin of error is E, which is equal to the critical t-value times the sample standard deviation divided by the square root of the sample size. Now, a robust procedure. Notice that a confidence interval about a population mean can be computed for non-normal populations even though students' t distribution requires a normal population. This is because the procedure for constructing a confidence interval is robust. It is accurate despite minor departures from normality. If a data set has outliers, the confidence interval is not accurate because neither the sample mean nor the sample standard deviation is resistant to outliers. Sample data should always be inspected for serious departures from normality and for other outliers. This is easily done with normality probability plots and box plots. Okay, let's look at an example. Constructing a confidence interval about a population mean. The website fueleconomy.gov allows drivers to report the miles per gallon of their vehicle. The data in a table below show the reported miles per gallon of 2011 Ford Focus automobiles for 16 different owners. Treat the sample as a simple random sample of all 2011 Ford Focus automobiles. Construct a 95% confidence interval for the mean miles per gallon of a 2011 Ford Focus and then interpret the interval. So here's the data. Step 1, we need to verify that the data are obtained randomly and the sample size is small relative to the population size. So because the sample size is small, we need to draw a normal probability plot to verify the data come from a population that is normally distributed and a box plot to verify that there are no outliers. So let's go ahead and do that. So in StatCrunch we have our miles per gallon. We're going to graph, QQ plot, miles per gallon, select correlation statistic. So therefore there is our graph. I'm going to go ahead and copy that. So there is our correlation statistic and our graph. Okay, so what do we know about R? Well, R is the correlation, which is 0.981. And so we need to compare that to the critical value and look at our sample size. Well, the sample size in our problem is 16. So down here, we can see that the critical value for when our sample size is 16 is 0.941. So it's greater than the critical value of 0.941. So therefore, we can say that it's a normal distribution. Okay. Now, next what we want to do is now we want to determine what is the box plot and verify that there are no outliers. So let's go to StatCrunch. Okay, we're going to go to Graph, Box Plot, select miles per gallon, use fences to identify outliers, draw boxes horizontally, and therefore there is our box plot. And so therefore, you can see that with our box plot, we do not see any outliers outside of those fences. So therefore, step 1 has been verified. Now in step 2, we want to compute the sample mean and the sample standard deviation S using technology. So we're going to come back up here, select Stat, Summary Stats, and go to Columns. Miles per gallon, the mean, and the standard deviation, select Compute. And therefore we get our summary statistics. So with our summary statistics, we can see that the sample mean is 36.8, and the sample standard deviation rounded to 2 decimal places is 2.92. Now what we want to do is determine the critical t-value with n-1 degrees of freedom. So the first thing we need to do is figure out the degrees of freedom. n-1. Well, the sample size is 16, so 16 minus 1 gives us 15, so we know the degrees of freedom is 15. Next, we're doing a 95% level of confidence, so that means alpha is equal to 100% minus 95%, which is equal to 5%, which gives us a decimal of 0.05. So to find the t-value, we're taking alpha and divide it by 2. That's 0.05 divided by 2. So that means the area to the right is 0.025. So we're going to use the degrees of freedom, which is 15. So coming down here, we have the degrees of freedom, rho. And then we're going to use the area to the right, which is 0.025. So here is 0.025, and then we're going to scroll all the way down there, and where they intersect is going to be the critical t-value. So the critical t-value is 2.131. Okay? So another way of looking at this is the following, right? Here's our graph. We have our area to the right is 0.025, and the critical t-value is 2.131. Okay, so now that we have all the information, now we can use the formula to determine the lower and upper bounds of the confidence interval for where the mean is, for the mean, where the sample mean is 36.8, sample standard deviation is 2.92, and the critical t-value is 2.131. So let's take a look at the lower bound. Okay, what do we know again about the sample mean? Well, we know it's 36.68. So therefore we have 36.8, Sample standard deviation is 2.92. So we know that S represents 2.92. And we know that the critical t-value is 2.131. And there's 2.131. And then we know that the sample size is 16. So let's go ahead and do that. So on our calculator, we have 2.131 times parentheses 2.92 divided by second square root of 16. And so we get rounded to 1.56. So if we take 36.8 and then subtract that number, so we're going to hit second answer, it gives us 35.244. And therefore we get 35.24 as our lower bound. For our upper bound, we're going to take again our sample mean. So we have our sample mean, which is 36.8. Add. So we have our sample standard deviation. And now we're adding the critical value, or critical t-value, 2.131. And there is our sample size. So, doing the same thing here, we know that when we find this result, 1.555630, now we're going to take this 36.8, and now we're going to add 1.5556300, and that gives us 38.35. Rounding it to 2 decimal places gives us 38.36. So our interpretation would be the following. We are 95% confident that the mean miles per gallon of all 2011 Ford Focus cars is between 35.24. If we use technology, it would be 35.25. and 38.36. Using technology would be 38.35 miles per gallon. In this example, the critical value of T is equal to 2.131 for 15 degrees of freedom. Whereas if we would have found this using critical Z, it would have been equal to 1.96. The T distribution gives a larger critical value, so the width of the interval is wider. This critical value using student's T distribution is necessary to account for the increased variability due to using sample standard deviation as an estimate of the population standard deviation. Remember that 95% confidence refers to our confidence in the method. If we obtain 100 samples of size n equals 16 from a population of 2011 Ford Focuses, we would expect about 95 of the samples to result in confidence intervals that include the population mean. We do not know whether the interval in example 3 includes the population mean or does not include the population mean.